So a uniform 50 kilogram crate rests on a horizontal surface for which the coefficient of kinetic friction is 0.2. Determine the acceleration if a force of P of 600 Newton is applied to the crate. So first, the first step in any problem is to draw the free body diagram. Okay, so I will put all forces acting on my box. I have the weight force, I have the normal force, I have P, and the friction. Here, how should be the friction? Of course, here for the box, it's always opposing. It's always opposing motion. So this is friction. Okay, because the ground is fixed, so it will oppose motion by a friction to the left. Okay, so these are my forces. I know the value of P. Okay, and the friction is mu kn. Now, for the normal reaction, can you tell me, is it at the center of the box?
No.
Why?
مش تحت على السيرفيس اللي داقه بالجراوند.
Yes, بس قصدي انه هي بنص تمرق بنص السيرفيس. Look, if the condition is to have translation, if my crate is translating, sum of moment about G should be what?
Zero.
Zero, very good. So the condition for translation is to have sum of moment about G is equal to zero. But if my normal reaction is passing by G, I might not have sum of moment about G equal to zero. So the normal position is unknown. How to know the normal position? The normal position should be in a way to ensure that sum of moment about G is zero. So I will put, this is my normal, I don't know where it is. I will say that this distance, I will name it x. So this is x. This is x. So my first unknown is x. My second unknown is the acceleration of my crate, ag. Okay. And what also? What is my other unknown? The normal reaction N. Okay? The normal reaction N. So to solve for Nx and A, I need three equations. But of course, I need here to do an assumption. So I will say I assume translation. I say I assume that I have translation. How can I make sure if my assumption is right or not? Who can tell me? What is the condition? What is the condition to have translation?
Sigma moment zero at G.
X equal to zero. Summation.
X should be positive, yes? X, the condition is X positive. Because if I obtain, so this is if I consider X from this side, okay? If I consider, for example, this distance here, this distance here, if I consider this distance as, let's say, I will call it D, okay? What is the condition for D to have translation? D can be maximum equal to what?
Maximum
0.5.
0.5, because if D is higher than 0.5, this means that my normal is outside of the surface, which is impossible. Okay, I cannot have a normal reaction outside of the surface. So assuming that I have translation require the condition that X is positive or D is smaller than 0.5. So what I will do, I will assume translation and calculate D. Okay? If I find a value for D higher than 0.5, I will say no, my assumption is wrong. So my crate is not doing translation, it's doing what? It will tip over. It will tip over which point? The corner point here. Okay? It will tip, if I call the corner point here A, this point, then I will start, my crate will start to tip over A. This means that the normal reaction, when the normal reaction will reach A, it cannot go any more beyond A. This is why my crate cannot continue in translation. It will start to rotate. Okay? And I can have two scenarios. It can rotate about a fixed point A, or it can do general motion. It can rotate plus translate. And we will
Miss,
see
what is D?
D is the distance between the normal reaction and the middle line.
Oh, okay, thank you.
If I take this middle line, okay, D is the distance between the middle line and the normal reaction. This one, okay, this line. Between this line, the middle line passing by G and the normal reaction. This is D. Okay?
دكتور
نعم.
مش ليكون عندنا translation
Yeah.
دي لازم تكون 0.5 على القد لا يقطع النورمال بالسنتر اوف
لا، لأنه أنت شو الكونديشن تيكون عندك translation؟ Sum of moment should be equal to what؟ Sum of moment about G. خلينا نكتبها. Sum of moment about G should
من
be
ورا
zero.
البي اوكي.
فأنت عندك البي، عندك المومنت اوف بي، وعندك المومنت اوف الفريكشن، وعندك المومنت اوف النورمال. واذا بتلاحظ المومنت اوف بي والمومنت اوف فريكشن اثنيناتهم كيف؟ اثنيناتهم clockwise. So the normal moment should be in the counterclockwise direction to be able to oppose. This is why N حتزيح towards the right. Okay. So now, yes?
Miss, can you please repeat why normal isn't in the middle? I don't get that part.
Okay, Jennifer. Because your condition for translation is that sum of moment about G is 0. Okay? So if you look at your figure here, suppose that the normal is at the middle. What will be sum of moment about G? If it's at the middle, the normal cannot produce a moment about G. So we will, because look, if it is at the middle, if the line of action of N will pass by G, so it will not produce any moment about G. And I have P is producing a clockwise moment about G. And mu Kn is also producing a clockwise moment about G. So in total, I will have a clockwise moment about G, which is impossible for translation. If I should have translation, N should create a moment opposing the counterclockwise moment. So it should give me a clockwise moment. So it should give me a counterclockwise moment. To give me a counterclockwise moment, it cannot pass by G. It should be to the right of G. When it goes to the right of G, it can produce a counterclockwise moment opposing the moment of P and friction. Okay, Jennifer?
Thank you. Yes, thank you.
Any other question?
I have a question, doctor.
Yes.
But sometimes if P doesn't have such a big value, and MUKN2 doesn't have such a big value, the box doesn't rotate. What is the force that is opposing this moment?
The normal. You cannot have the normal. If P and mu K are like this, the normal will not be at the center. It will move to oppose these two forces. But if you have a very large force P, so N cannot anymore oppose because it will reach point A and still it cannot oppose P, then you will have rotation.
Thank you.
Okay, so now let's continue. So as we said, we will assume that we have translation. We will put our forces and we will write the three equations. The first equation is sum of forces equal sum of x equals MAGM. So if I go back to my free body diagram, if I do sum of x, what do I have? Plus 600 minus minus mu kn, so minus 0.2 nc equals to MAGX. This is my first equation. Second equation, sum of Fy equals MAGY. But here I don't have motion along y because my block is moving on the horizontal plane. So sum of y is equal to 0. So I get that the normal reaction is equal to the weight. Now, the third relation is sum of moment about g or about any point I want. If I consider g, for example, because I assume translation, sum of moment about g should be 0. What is the expression of sum of moment about g? I have first the moment of the force p. Okay, so if I consider the counterclockwise as positive, so I have minus p times which distance?
0.3.
0.3. Okay, and if I consider the moment of friction now, friction has also a clockwise moment, so it's negative. So minus 0.2 nc times which distance?
0.5.
0.5. Okay, and I have now the opposing moment of n, which is plus nc times which distance? X. They call this distance x. Okay, so now I have three equations with three unknowns. I will solve them, and after solving I should not forget to verify what? I should verify that the value of x that I obtained should be smaller than 0.5. Here I got x equal to 0.467 meter, which is smaller than 0.5. So I can say that my assumption is true and I can stop here. The problem is if I obtained x higher than 0.5, I should repeat everything because I say, no, I cannot have translation, so I have tipping over and I solve my problem again. Okay?
بس
Yes.
إذا طلع مثل ما أنت قلت greater than 0.5
Yes.
بتصير سيجما ام جي مش زيرو، يعني بصير بدنا نلاقي
مظبوط.
point
اول
A
شيء اذا شو
moment.
بيصير هلا رح نعمل the problems that are similar to this. رح نعمل
Okay.
scenarios where you get that sum of moment is not zero. Okay?
Okay.
If you want, I will explain it here and then we will do it numerically in other examples. فنفترض طلعت x higher than 0.5. What we should do is first normal reaction بتصير أكيد على أي point؟
على point A.
على point A لأنه خلص the normal cannot move anymore. So it will be at A. يعني خففنا one unknown شو كانت اللي هي x. Okay? بتبطل x unknown لأنه we know that n is at 0.5 meters from the center. But what will be the additional unknown here? Because
Alpha?
we have rotation, we will have alpha. Okay? But now we have two possible scenarios. The first scenario, okay? So if not translation, we have first possibility, we have rotation about fixed point, and this fixed point will be A, about fixed point A. Can you tell me what is the condition to have fixed rotation, you know? How should be the friction at A? If I really have rotation about a fixed point, the friction at A should be static.
Zero.
Static, no, not zero. It should be a static friction. So what is the condition? So the condition is that friction at A is static. And how to verify that the friction is static? What is the formula? I should have F smaller than what? smaller than mu s, smaller than mu s times n. Okay, so here this is my new condition. My new condition is to verify that friction is smaller than mu sn. If it's not the case, then I will say no, I cannot have rotation about fixed points. I will have general motion. Okay, so in case I assume rotation about a fixed point, my additional unknown will be the friction. The friction is unknown. I will call it f. Okay, but I should verify at the end that it should be smaller than mu sn. So they should give me in the problem the value of mu f. So I will put that my unknown now is f. Okay, so I have now how many unknowns? My unknowns are, in this case, f, ag, what also? What additional unknowns I have? Normal and alpha. So I have here 4 unknowns. How to solve this problem? If I have 4 unknowns, I should always think about a force relation. The force relation, you always get it from kinematics. Kinematics can relate what and what here? Who can tell me, can I relate Ag and alpha using kinematics? For pure rotation, when you have pure rotation about a fixed point, what is the relation between Ag and alpha?
R times alpha يعني AG
Very
times
good.
alpha.
Very good. So when I say rotation about fixed point, I can add the relation that Ag is equal to alpha times R. What is R here? The radius of rotation of G about A. So
Radical 2 or
which is the distance between A and G. Okay? So times Ag. This is my force relation. So now I can write 4 equation with 4 unknowns, and I solve for my 4 unknowns. Once I finish, I should make sure that f is smaller than mu sn. If f is not smaller than mu sn, then I'm not lucky at all. So I should do the third step and say that I have general motion. If I have general motion, just means that my block will rotate and translate at the same time. Can you tell me in this case, so in the third case, what will be my unknown? So in case I verified that it's not translation, and I verified that it's not pure rotation about A, then my final case, which is, of course, will be the true case, will be general plane motion. This means that I have rotation plus translation at the same time. Okay? But at least in this case, what will be my friction? Can it be static?
No, it will be kinetic
Yes. So my friction is not static anymore.
because
So
A
I
will be
can
moving.
say that friction is kinetic. And then I reduce the number of unknowns because f will not be unknown. F will be equal to what? Mu kn. Okay, so f is equal to mu k times n. So what are the unknowns in this case? The only unknowns will be, so I have only 3 unknowns. My unknowns are, I have ag x. Look, but here I have agx and agy unknown. So I have agx, agy, okay, and I have alpha and n. So here also I have 4 unknowns. How can I get a force equation here? Who can tell me? I cannot use that a g vector is alpha times r. Okay?
You can use all اللي بتشابتر 16 كانوا الايكويشنز الطوال بتاع
Very,
relative acceleration.
what I can do, I can relate acceleration of A to acceleration of G. You know why? Because A, G are 2 points of one rigid body, and the advantage to relate to A is that for A, I know the direction of acceleration. A will move along what? Along the horizontal line. So when I write the relation between AG and AA, I will get two additional equations, which will give me expressions for AGX and for AGY. Okay, so it's true that I am adding an unknown. By relating AG to AA, I'm adding an unknown AA. But at least when I relate AA to AG, I obtain two equations. So in total, I will have 5 unknowns, which is AGX, AGY, alpha, N, and AA, but I will obtain 5 equations. So I can solve my system. Do you want me to repeat anything? Is it clear, the 3 steps I did? Okay, so let us do another problem. Now, we will consider equation of motion for rotation about a fixed axis. Okay? So, if we consider rotation about a fixed axis, we can write the following relations. First, sum of moment about G is IG alpha. Okay? And the acceleration of G will be divided into normal and tangential components. Why? Because when we have pure rotation, then G is rotating about a fixed point. So G is moving on a circle. And when G is moving on a circle, I can find the acceleration of G as tangential acceleration is alpha times RG, and normal acceleration is omega square RG. Now, concerning sum of moment, I can write it as sum of moment about G, or I can write it as sum of moment about O. Can you tell me how we can demonstrate that sum of moment about O is equal to IO alpha? Who can tell me? Why? Why is the point is fixed? Sum of moment about O will be IO alpha.
because لأن يمكن البادي كله rigid body عم يعمل rotation.
No. Look.
فإف we use the equation اللي برهناه قبل شوي.
برافو. if we use the equation اللي برهناها قبل شوي. Let's go back to the previous relation. Look, we have that sum of moment about P is equal to minus y bar MAPX plus x bar MAPY plus IP alpha. But if P is fixed, if P is not moving, what will be APX and APY?
They will be 0.
0, of course, because a fixed point doesn't have a velocity and doesn't have an acceleration. V is 0 and A is 0. So when P is fixed, APX is 0 and APY is 0. So sum of moment about a fixed point is equal only to IP alpha. This is why in case of rotation about a fixed axis passing by O, I can say that sum of moment about O is equal to IO times alpha. So for pure rotation, you can apply the relation or about G or about the fixed point of rotation. Okay? So the 3 equations I will get are sum of n equals MAGN equals, and AG normal is MV square, AG normal is V square over R, but V is what? V is R omega. So I can replace V square over R by omega square times R. Okay? And sum of tangential force is MAG tangential equals to M alpha RG. and sum of moments about O is IO alpha. Okay? Now, let us do examples on pure rotation. Okay? The unbalanced 25 kilogram flywheel has a radius of gyration of 0.8 about an axis passing through its center of mass G. If it's released from rest, determine the horizontal and vertical components of reaction at the pin O. So here, first we will draw the free body diagram showing all forces acting on this disc. We have the weight. Here, because it's an unbalanced wheel, the center of mass is not at the center of this disc. Okay? Because here you can see that we have different materials of the disc. So this is the weight. And we have the pin reaction. Because it's a pin, we have OX and OY. So our unknowns are, we have as unknown OY, the vertical reaction. We have OX, and we have the acceleration alpha. So alpha is unknown, and of course AG is unknown. Okay, but always when you have a rotation about a fixed point, you can always relate AG and alpha. Okay, so because you have pure rotation, you can say that AG is equal to alpha times R, which is the distance between O and G. So the first relation you can use is that AG, A of G, is equal to alpha times OG. Okay, and here AG will be in which direction? AG is always هيدي الاي جي اللي كتبتها بليز انتبهوا هيدي اي اي جي توتال شيء guys the AG I wrote here is the total acceleration or what?
Yes, مش هو it is doing only rotation.
ايه بس ما نحن قلنا الاكسلريشن is always decomposed into tangential and normal. هيدي الاي جي هي اي acceleration?
So this one is the tangential.
This is the tangential acceleration. AG tangential. So please pay attention. You should always take into consideration tangential and normal. But here, what is the normal acceleration? نحن عادة normal acceleration بنجيبها omega square times r اللي هي OG. But what did they say here? It's released from rest. If it's released from rest, so what is omega at the initial state? 0. So at the initial state, no normal acceleration. I only have tangential acceleration. This is why my AG is restricted to the tangential component and it's in the vertical direction. Okay? So now I can write my other equations. My other equations are sum of fx equals MAG x. But what is AGX here? It's 0 because now I demonstrated that my acceleration is restricted to y direction. Or I can say, if you want, if I'm working in normal tangential, it's better to say sum of f normal equals to 0 because a normal is 0. So I only have in the normal direction, I only have minus OX. Why I put minus OX? Because UN is always directed towards the center of rotation. So UN is directed like this. Okay? So I can, from my first relation, I can get that OX is 0. Now if I apply the second relation, sum FT equals to MAT, A tangential. What are my forces along UT? I have plus W minus OY equals to MA tangential. Okay, This is my second relation. And my third relation is sum of moment. I can apply sum of moment or about O or about G. But it's better to apply it here about O to cancel the moment of OX and OY. So if I do sum of moment about O, I get that it's equal to the weight W times the distance 0.15 equals to I inertia about O times alpha. And how to get the inertia about O? Who can tell me? How to get
half m r squared.
Look, the radius of gyration is about an axis passing by what? By G. Okay? So I can use the parallel axis theorem to find IO because IO is equal to IG plus
mg
mass of the
squared.
disk times distance between O and G, so times OG squared. Okay? And what is IG? What is the inertia about G? Because they gave me the radius of gyration, it's m times kg squared. So when they give you the radius of gyration and they said about G, so you do mkg squared to give you IG. Then you add MOG squared, which will give you IO. But if they tell you the radius of gyration about an axis passing by O, then directly you do MKO square without adding anything. Okay? Any questions on this problem? So everything is clear? Okay. So let us move to another problem. The drum shown has a mass of 60 kilograms and the radius of gyration KO equal to 0.25 meters. A cord of negligible mass is wrapped around the periphery of the drum and attached to a block having a mass of 20 kilograms. If the block is released, determine the drum's angular acceleration. Okay, so here we want to find what is the angular acceleration of the drum. So let us do the analysis of this problem, put our unknown and try to write the corresponding equations. So first, if I put the free body diagram, I have at pin O, I have OX and OY. I have, of course, the weight of the disc and of the pulley, and I have the weight of my block. Okay? Now, what I want to find is alpha. And they didn't ask about OX or Y. So when they just tell you find this unknown, try to minimize the number of equations. If I want to get rid of OX or Y, I don't want to involve OX or Y in my calculation. I should do sum of moment about which point?
Oh.
Oh,
Very good. I should do sum of moment about O. And in this case, okay, I will take the two bodies. I have the box and I have the pulley. So first, I will take as my I can take the pulley alone, and I can take then the box alone. Or also another possibility, I can consider the whole system. I will do both for you. Okay. For now, I will take the disk alone and the box alone, and I will write my equation. If I take the disk alone, what are the relations? I have sum of moments about O equals to IO times alpha. But if I take the disk alone, what should I add as force?
Tension.
Tension, very good. I should add the tension force, so I'm adding an unknown to my problem. I'm adding T, okay? So my first relation will be IO alpha equals to sum of moment about O. The only force doing moment about O is what? Is the tension. So it's equals to T times R. This is my first relation. Now, I have two unknowns. I have T and alpha, so I need an additional relation. I will now go to the block. Okay, if I go to the block, what is my relation for the block? If I do the second law of Newton, I can write that sum of forces along y. Okay, I can take y downward here if you want, because I know that the box is moving down. So it's equal to w minus t equals to m times acceleration of the block. Okay, but now I have three unknowns, alpha, a, and tension. I need a third relation. What will be the third relation?
فينا نقول إنه A is equal to S alpha
A is
أو لا
equal to alpha r. Why A
إيه
is equal to
alpha
alpha r? Because look, here I have rolling without slipping. Okay, when they don't say anything, it means that I have rolling without slipping. Because I have rolling without slipping, the tangential acceleration at A can be calculated from alpha r. Because when I don't have slipping, the acceleration of the block is equal to the tangential acceleration of my chord is equal to alpha times r. So my third relation is A is equal to A tangential at A is equal to alpha times r. So I obtain three equations with three unknowns. I can solve for my system.